A scheme syntax calculator is a scheme interpreter that does not support many features of scheme, but does include the arithmetic operators of scheme, plus, minus, times, and divide, as well as call expressions, which can be nested. An interpreter for this language is stored in schemecalc.py, which gives me this prompt and allows me to actually add things together and perform nested arithmetic, including on floats. So more than just reading this expression is happening, now that expression is being evaluated. So we're going to take a look at the contents of this file, which includes some examples and has only two functions: a function to evaluate an expression and a function to apply a particular procedure to some arguments. So I can apply plus to 1, 2, 3 to get 6, and I could evaluate an expression such as plus 2 times 4, 6 to get 26. The calculator language has only primitive expressions and call expressions. The primitive expressions are always numbers, and the call expressions are combinations that begin with plus, minus, times, or divide. Expressions are represented as scheme lists, which in Python are pair instances, and they encode the nested structure of each expression. So an expression that looks like this would be represented using an expression tree and represented in Python as pairs that have the following structure. Now, calculator semantics is pretty straightforward and matches exactly what scheme does. The value of a calculator expression is defined as such. A number evaluates to itself, and a call expression evaluates to its argument values combined by an operator, where plus sums the arguments, times computes the product of the arguments, and minus and divide are a little more complicated. Minus doesn't work if there's 0 arguments. If there's 1 argument, it negates it, and if there's more than 1, it subtracts the rest from the first. Divide, like minus, does something special with 1 argument, takes 1 divided by whatever the argument is, and if there's more than 1, divides the rest from the first. So, for example, I can divide 3, gives me 1/3, but if I divide 2 by 3, I get 2/3. So here's an expression tree, and the evaluation process tells us that 2 times 3 is 6, 2 times 5 is 50, and the plus adds all of those together to form 61.